One of the things I've bought recently to improve the usefulness of my lathe was this tailstock die holder. So the way this works is this goes into the tailstock and your dies fit into this holder. It comes with 4 different sizes, and at first I wasn't sure how that worked because the pictures only showed the 2 die holders here, but it's actually built into the handle. So you can see there's a small size there, next size up there, and then you've got these 2 additional ones, and the way they work is they just get fitted into the end to make the holder bigger. This piece goes into the taper on the tailstock, and then this can slide up and down. It's kind of a nice fit in there so that you can hold this and use the lathe to advance the die down the length of the thing you're trying to thread. Probably in my case it'll be studs. But I made a slight mistake when I ordered this, and I got one with a Morse Taper 3, an MT3 thread. Unfortunately that does not fit my lathe, which is an MT2 thread, slightly smaller. So I can fix this, of course, because I have a lathe. So what I'm in the middle of doing is turning up a new one of these, and I've turned up the end that the holder slides on, so that goes up and down on there, and I'm about to take this out and turn it round and turn the taper on the end. And a good trick I saw about how you do this is you need an existing taper that you can chuck up in the lathe chuck here. You put this in the lathe jaws like that, and then you're able to use this edge of it as a reference to set up your compound. So the idea is you get something parallel. I'll use one of the Mill parallels and set it up so that this matches the angle of that, and then theoretically I can use the slide here to machine that angle to get the right taper. So I've never tried this. It'll be interesting to see if it works out, but I think it should. It's a bit hard to see because the angle is so small. I had to actually look up what it is, and it's something like 1.4 degrees, I think. But with a Mill parallel sort of pushed in, I'm assuming that the sides of this compound are machined. They look like they are machined, so I'm pretty sure they're parallel. And you can sort of set it up like that to get the angle that you need, because there's no way I could measure it accurately off here. The scale is just far too coarse. So the other thing is there is a maximum dimension for this big end of the taper, which is 0.7 of an inch. So on my little bar here, I've machined that down to that size. So I know once the taper hits that, I've hit the right diameter. This steel is it 4140, 4041 high tensile steel? I can never remember which way around the numbers go. This is my taper turned up. It was a little bit tricky because the slide on my little lathe couldn't do the full length in one go, so I sort of had to do half and then come back and do the other half and get them to join up in the middle. I gave it a little bit of a polish with some wet and dry, and then a bit of scotch polishing stuff. So I guess now I just need to take it out and see if it actually fits. That's the finished taper in place, and it actually works pretty well. So the handle stops it turning. I may make a slightly shorter handle so I can actually turn this and keep the lathe chuck still, There's two ways you can do it really. But it actually worked a little bit too well to start off with, and I forgot that you need the little end piece on the end of the taper, just enough so that it'll extract itself. And the first time I fitted it, I actually had a hell of a job getting it out. So what I've ended up doing was I drilled the end and put in a M6 socket head screw. I'm actually recycling parts because that's a screw that originally came with this. So I got to reuse it there. I did forget that this is high tensile steel, and I broke one of my taps when I was tapping it, but luckily I was able to extract it, and the threads had gone far enough that I could get that small screw in place. Let me just wind this out. But that's pretty tight in there. Finally, to finish it off, I gave it a dip in the gun bluing solution. I never have that much luck with that stuff. It's really hard to get an even finish, but it should give it some degree of corrosion protection, I hope. I think that should work okay though. Final thing for tonight. I think it's easier for me to do shorter, quicker films because then I don't forget what I've already talked about and ramble on about the same things over and over. But I 3D printed a little drilling guide. The idea being I could sit that onto my steel blanks and punch through the holes. The very first hole I did, I ended up smashing the guide, but you can see it broke around the hole, so all I ended up doing was still using the guide, but I just poked through the holes with a fine point Sharpie, and then I was able to punch them. I was also able to do the same on the little mounting bracket thing, which I should probably machine that face. I've run a file across it, it's fairly flat. And my idea was to bolt the blanks to this with high tensile 6mm bolts. But unfortunately it was my 6mm tap that I broke. Luckily I've got some high tensile 1/4 inch UNF bolts and a matching tap. And being UNF, I'm not likely to use these on the Riley. I always feel bad about using up my BSF hardware because it's expensive and hard to get. These I'm not likely to use for anything else. So the idea will be these will go through this, and again with my 3D printed mock-up you can see that the thread doesn't come through. So there's at least 3 threads that poke through deeper than a nut. So I figure if I drill and tap the blanks so that I can screw 3 of these bolts through from the bottom, that should be enough to hold it firmly on my fixture so I can then mill the angles. I do want to wait until the little angle measuring box that I've ordered arrives, just to make sure that I get the exact right angle. So the angle, if you look at it that way, is 8 degrees, which matches up to the 82 I measured on the chassis there between the side rails and the cross member. So I think that should work. Hopefully that's enough to hold it all securely. I was thinking about adding a little spigot in the middle that can fit onto, but I'm going to try it just bolted first and see how I get on with that. If that doesn't work, I've got an extra one of these, so if I screw one up, that's okay. But if that doesn't work, I can then always drill this and put in a little center mounting spigot thing just to keep it really accurately aligned. I'm pretty sure the bolts should be good enough though. I just remembered, after I've finished marking out and punching the holes where I need to drill these, that the the mill actually, the DRO has a hole drilling function on it where you can set the 0 position, set the radius of the holes, I think it's about 28 millimeters, start angle, finish angle, number of holes, and I think this means direction, which is this chart here, just showing which way round you want to go. And now it'll give you the positions to move to drill each of the holes. So from the center, you would go -28 in the X direction, and it gives you the absolute coordinates that you need to go to. So you can sort of zero that, drill that hole, and then go to the next one, and it shows you where to move. So that would have been an option as well. That would have been quite cool to play with, actually. I decided, since I pretty much had this all set up and programmed and dinner isn't ready yet, I might as well go ahead and drill the holes on the mill. So I set it up so that my punch marks were on the correct axes, just so I could check to make sure it was all working correctly. And I went and checked in my model to make sure I had the right radius and things like that. And it actually works really well, and it doesn't work exactly how I thought. Basically, as you move from hole to hole, it shows you how far you need to move. You basically need to move the dials back to 0 to go to the next hole. So you can see that's moving along. You sort of 0 this, and then 0 it in the other axis as well. I won't get it exact, but you can see it's now lined up on the number 2 hole. I'm going to go ahead and drill the rest of these because now it's all set up. I think all I need to do is recenter it, and luckily the center drill I'm using is pretty much exactly the same diameter as the hole that they machined in the middle of these cutoffs. So that makes setting up the center really easy. I think I forgot to mention what I'm actually going to do, because these brackets aren't really structural. Effectively, they're just a spacer, and the pin itself is like a giant bolt, and that's where the strength is. That's what's actually holding it to the chassis rails. These are just there to take up the space. So effectively, they're almost just cosmetic. So what I'm going to do to replicate the original look of the riveted on forgings is I'm going to get hold of some probably M8 coach bolts like this. And my plan is, once I've milled these flat, I don't need these holes to be threaded anymore. So I'm actually going to drill them out to be 8mm, and I'm going to get coach bolts that are longer, where the thread doesn't come all the way up. So I can cut off the metric thread and rethread the end of the bolts to be 5/16 BSF, because I've got lots of 5/16 BSF nuts. And I'll probably just hand file, because it only needs to be on the outside, so it's only 8 holes, the little squares that I need for the coach bolt heads to fit in and not rotate. And that should replicate the look of the rivets that hold these on. It's going to hold them in place. As I say, they're not really structured at all, they're just cosmetic. And by rethreading the bolts, it'll have the right size nuts on there. I think I've mentioned the reason that's important is because the spanner sizes are different between BSF, BSW, and metric. So it would be really annoying to have a mix of metric and imperial fasteners on the car, because then you need 2 sets of spanners. So that's my plan at the moment. I'm going to finish drilling these at least. I don't think I'll tap them tonight. I've already broken one tap today. I don't want to risk breaking another, although this is just mild steel, I think, not hardened steel, or not high tensile steel. But now I've drilled one of these. Using the DRO like this, it took me no time at all. It's really easy. So sometimes it's a matter of remembering what tools you've got and knowing how to use them and just playing with them to figure out what you can do. So I didn't need to do that 3D printing and marking out and all that kind of stuff. I can just do it all on the machine, which is pretty neat. All the holes are drilled now. That went really well. And it just shows that even a fairly cheap mill like this, with a cheap DRO setup that I've added on myself, leads to far better accuracy and repeatability than I could do just measuring things by hand and drilling them by hand. A couple of things I did learn. One, of course, the display works by showing you how to get back to zero for each hole, because with a display like this where there's only one digit per, or one set of digits per axis, how else could it work? It has to reference to something, so of course you have to go back to zero. The other things I figured out is, because of the way I've set it up and the way the holes are numbered, it kind of goes 1, 2, 3, 4. You don't have to drill the holes in order, so you don't need to go in that order. You can just basically step through the holes and drill them in the order that you want. And it makes sense because I'm drilling 4 holes to do them in pairs. So 1 and 3, 2 and 4, because then it means you're only needing to translate in one direction between each set of holes rather than 2, which makes it a lot easier as well. Also, I had to remember to support both sides of the hole when I was drilling it. I've got another one of these blocks under the center there to lift it up, and you need another one, of course. So I did have to stop between this hole and this hole so I could swap the block over. If I had more of them, I'd just put a block under either side. And the only other thing is, don't lose count of which holes you've already drilled and take the piece out before you've drilled them all. Luckily, it was pretty easy for me to get it reset up and realigned to drill the last 2 holes after I accidentally took one out before I was finished. But I'm pleased with how that came out, and I think it'll be a job for tomorrow night to tap the holes in these. Those I will probably just do it by hand on the vise. I don't really have all the gear set up to do proper machine tapping. You need sort of ratcheting clutches and things to make sure you don't just break the taps. So that'll be a lot safer for me to do by hand. But I'll leave it there for tonight.